Okay, before I have my breakfast here, I want to do a little review of solids. So these are all solids, but to do solids, we need to go back and talk about area and perimeter. So we did this kind of interesting thing in class the other day where we had this inscribed pentagon inside of a circle. And there was all this vocabulary, and one of the things we had to review right away is to remember that from the center to the edge of a circle is a radius. And we talked about how the plural of radius is radii. It's because radius is from the Latin, it means spoke of a wheel, which is a good name for it. It's like a spoke of a wheel. But because it's Latin, the plural is radii. So if you hear people say radii, they're talking about radiuses, but they're multiple, more than one radius is what they're talking about. Okay, so we did something called decomposition, which is breaking a shape apart into things that we know so we can figure out the things we know and then we can recompose them into the original. So we decomposed this into this picture over here. And through a little math magic, we discovered this was 36 degrees. This thing was already listed, our radius was already at 10. And we did a little math magic to figure out our opposite and adjacent, and ultimately, I've lost my key. Oh, there's my key. I can tell you what we did. We ultimately figured out that what the sides were, so we could figure out the area of the triangle. So we found this side and this side, and we did 1/2 base times height because somebody remembered our formula for a triangle. We multiplied those two numbers together, and we came up with, I think it was 23.9. For the area of that, areas in units squared, whereas this is 10 units when we're measuring in length. And then we said, okay, now that I have this part right here, and I know how many of those parts there are, there's actually 10 of those. We multiplied times 10, and we said, oh, that pentagon must be 239 units squared. So many little squares would fill up that pentagon. And then we also were able to find the perimeter. So once again, the perimeter is the distance all the way around an object. For a circle, we say the circumference. It's a fancy name for perimeter. And we were able to discover, oh, this right here matches up to this right here. And we found out that number was 5.9. And then once again, we're like, well, we have 10 of those going around the edge. So we did the 5.9 times the 10 to figure out that it was 59 units all the way around the pentagon. And then we did a little checking to make sure we were right. And we were like, well, it's got to be less than the circle. So somebody remembered that the area of a circle is pi r squared. We already know our r is 10. So 10 times 10 is 100. So the answer here, it's 100 pi units squared. But that doesn't mean much people. So we plug in 3.14 in for pi to get 314. 314 units squared is roughly how many this is. And then we did one that was slightly bigger, and one that was slightly bigger, and then one that was slightly bigger, and it's getting closer and closer to the circle. And as we got closer and closer to the circle, it got closer and closer to that 314 number, but it never went over that. And we did the same thing with the circumference. And the circumference, somebody remembered that the distance around the circle, there are a couple different formulas people remembered. There was 2 pi r, which is the same as 2r pi. And if you string two radiuses together going all the way across the circle, that would be two radiuses going all the way across the circle. That's what's called a diameter. And that's the formula that I like. So because 2r is diameter. So all three of those are formulas for, let me zoom in a little bit. I think I can zoom in a little bit. So all three of those are formulas for circle. There's all the work if you're having trouble seeing it. A little zoomed in a little bit now. So diameter is 20, and 20, so 20 pi units is how far it is around the circle, but 20 pi doesn't mean much to most people, so we plug in 3.4, and we get, oh, it's about 62.8 around the circle there. So that's a little review of what we did in class, plus it's a lot of review about area and perimeter. So before we do volume and surface area, and before I eat my breakfast with my props, we're going to need do a little bit of review around area and perimeter. So you have a little quiz. All right, so we got three shapes because the basic building shapes of pretty much everything tend to be rectangles or squares, triangles or circles. Those tend to be our building blocks. So my question is, what's the area for this rectangle? That's right. It's going to be just base times height, or 3 times 4. So that thing is 12 units squared, or inches squared, whatever I'm measuring in. What about for the triangle? What's the area? Well, if it was a rectangle, it would be 2 times 5, it'd be 10, but most people remember, oh wait, the formula for a triangle is 1/2 base times height, or some people will say base times height divided by 2. It's the same thing. So 2 times 5 is 10, and then 10 divided by 2 is 5 units squared. So how many little squares would fill that thing up? And then finally for the circle, now that we remember our formula is pi r squared, or r squared pi, whatever you prefer. 3 times 3 is 9, so that's 9 pi, which is fine, but sometimes we'll plug in the 3.14, which I think is 27.26, I think. I'm doing that from memory. I don't remember if that's wrong. Just know I got it wrong. No, that is wrong. It's 28.26. I think it's that. I used to have that memorized. Look it up. All right, and once again, but we're still units squared. All right, so down here, perimeter. Okay, let's go back to perimeter. What's perimeter to top one? So you can have a formula perimeter. I think it's a waste of time for a formula perimeter because all you have to do is add up all the exterior sides. So 3 plus 4 plus 3 plus 4, that is, for that thing, it's going to be 14 units because now I'm measuring distance, okay? So 14 units for that one. For this one, little trickier. I don't know this, so either I have to tell you that or you have to know how to use Pythagorean theorem to figure out 2 squared plus 5 squared equals c squared. So 4 plus 25, it's not 29, it's the square root of 29. So that is the perimeter. 2 plus 5 plus square root of 29. I could say the perimeter for that is 7 plus square root of 29. That is a fine answer in whatever units I'm measuring in. But then if I want to turn that into a number, that number I think is 5.4. So I can say, well, that's 7 and 5.4. And so that's about 12.4 units around it. But 7 plus square root of 29, that's the exact answer. That 5.4 is rounded. It's no longer exact. All right, last one. Once again, you got to remember your formula. Pretty sure it's going to have a pi in it because it's circular. And then if we remember that, it is, I like diameter times pi. And so it's 6 all the way across that thing. So it's just 6 pi is my answer. And then whatever 6 times 3.14 is would be the decimal version. And my wife's coming in, so I'm going to have to yell at her to tell her I'm filming. Hey, honey, I'm filming. Don't interrupt me. Okay, what's next? We did that, and so we did that because one of the things that you might have to do is do something called decomposition. So if you had this shape right here, you now have the tools to figure out what that is. So see if you can't figure out what the area and perimeter of that is. Do the area first. All right, so the area for this thing is going to be half of pi r squared. We know this thing is 2 by looking over here. So 2 times 2 is 4. It's pi. So, but it's going to be half of that because it's half a circle. So it's just going to be 2 pi. 6 times 4 is going to be 24. And then 4 times 3 is 12, but it's half of that. So that's going to be 6. So if I add those 3 together, that would be my area. And then the tricky part here, there's only one tricky part here, I think, for perimeter. We have to figure this out. 3 and 4, this is a Pythagorean triple, this is 5. Don't add that 4 in. That 4 is not part of the perimeter. It's only interior. So this is, the perimeter would be 6 here, plus another 3, plus a 5, plus a 6, plus 1/2 of diameter pi, which I think is also 2 pi. Strangely, those both came out as 2 pi. So that's how I would figure out the perimeter. Okay, now the main event. So the main event is we want to figure out the area of these things because these are the most common shapes, except the egg is not really a common shape. I'm just having it for breakfast. So instead of the egg, we're going to use this thing because a sphere, okay? It's a lacrosse ball, I think. All right, Let's do the butter first. But before I do the butter, we need to get some units, and I need to do a little vocabulary review. So I'm going to turn this over so it's not distracting and get something else here. And I couldn't find my Rubik's Cube. So I glued a bunch of sugar cubes together, and so that's going to be our unit of measure. We're going to have one sugar or one sugar. That's our unit. Okay. So when you look at this, there's some vocabulary I need to talk about here. So you might call this front part here the side. The problem with calling this as the side is this thing right here. Somebody could also call it the side because it's kind of the side of the rectangle in the front. So this thing on the front, this flat area, is called the face. Okay, so that's a face, that's a face, that's a face. This thing has 6 faces. This part right here that comes together between 2 faces is called an edge. And this part over here that you might call a corner, that's kind of a problem too, because you might call the edge a corner, because these two comes out, that's kind of a corner. So we typically call that a vertex, which we know that word already. Vertex, like an angle has a vertex. This is the vertex is where the 3 edges come in together, where the 3 planes meet is called a vertex. And once again, our plural for vertex is vertices. All right, so let's talk about the surface area and volume of this rectangular prism. This is called a prism, P-R-I-S-M. Think of it as a building that stands straight up. And if I look at one face of the building, I can clearly see there's 1, 2, 3, 4, 5, 6 squares on there. If I stand it up, this area around the building between the top and the bottom is often called the lateral area. So my lateral area is 6 plus 6 plus 6 plus 6. There's 24 square units or square sugars in the lateral area, and then if I add the top and the bottom, which is often called the bases, there's another 4 and 4. So we got 24 plus 4 plus 4, 32 square sugars squared are our units for the surface area. It's covering it. So it's a little bit like perimeter. It's everything on the outside. There are some little surfaces inside here, but we don't count the internal surfaces in the same way we did not count this 4 on the inside of this thing when we were doing perimeter. Okay, so let's talk about volume. Volume is easy. I love volume. Once again, if you think of it as a building, if you think of a prism, the top and the bottom will always be the same. It could be any shape. It could be a triangle, could be a circle, could be some weird shape. The sides have to be straight up and down though. Otherwise it's not a what's called a right prism. Okay, so think of it as a building. How many do we have on the bottom floor? How many cubes? We have 4. How many stories is the building? It's 6. So we got 4 on the bottom and 4 and 4. 4 times 3 is 12, and we have 12 cubes, which I can count, but I don't need to count, but I could count because this is a simple shape. Okay, so 12 cubic sugars cubed. That's how many we got there. So now let's do another one. All right, let's do our butter building. Okay, here's our butter building. Slightly bigger than our sugar building. Okay, we are going to say that this is 5 high. It's roughly high. It's not 2 times as high. It's about 5 high. So it's 5 high. And when we measure it out, it is, I'm going to say it's 2.5 wide. So this is 5 by 2.5. And I did all these calculations ahead of time, so I'm checking my notes here. That's going to be 12.5 high for one face. And I got 4 of those in the lateral area. And so 4 times 12.5 is going to be 50 square shugs all the way around. And then I have to do my bases. And I've kind of already measured that. It was 2.5 going this way and 2.5 going this way. So 2.5 times 2.5 means that's 6.25 shugs, square shugs that fit there and on the bottom. And so when I add the 6.25 and the 6.25, that's together, that's 12.5. And when I add it to the 50, there are 62.5 of these little size sugar squares that would fit all over this thing. Now, what occasionally you will see is something called a net, which I did a sketch of. Okay, so this is kind of what the butter looks like when you unfold it. Let me see if I can't zoom out a little bit. Yeah, this is what the butter kind of looks like when you unfold it. And so this is called a net. And from this net, it's a little easier for me to figure out. Oh yeah, I can see the lateral area is 5 by 2.5. I've got 4 of those. I can add all those up. That's all 50. 2.5 times 2.5 is 6.25. One down there too. So you will see these things called nets occasionally, and they make it a little easier for you to figure it out But honestly, as long as you know what the shapes are and you can figure out the areas of each one of the shapes, you're just adding them all up. There's no need for a formula. I've seen formulas for these things before, and I think they're a waste of time. All right. Now, there's one shape we left out in our breakfast. We don't have any triangles for breakfast. But what we could do is something like this. Okay? We could take this thing and split it triangularly. So what would that do? How would that change our calculation? So if we split this thing across the edge there, well, volume-wise, it would just chop the whole thing in half. So it would be half as much. I could figure out the area of that triangle would be 2.5 times 2.5, but it would be half of that, and then I'd still multiply it times a 5. So it's our original number of 62.5, but chopped in half, which comes out sorry, our original number was, we didn't do volume yet. Oh, I skipped something. Yeah, so we forgot to do volume. So volume, it was 2.5 times 2.5. So there's 6.25 on the bottom, and it's 5 high. So that is the 31.25 that I just realized from my notes I forgot. But if we chopped it in half, that 31.25 number, that would be the whole thing. Once again, 6.25 on the bottom, 5 high. There are 31.25 cubes in it. If I chop this thing in half, it chops all the cubes in half. It chops the bottom in half. So I could just figure out the area of that triangle, because I know the formula. That's how many are on the bottom floor, and I multiply it times how high the building is. Okay, so doesn't matter what the shape is on the bases, as long as I can figure out the area of one of the bases, then I just multiply it by the height for the area. All right, so it doesn't matter if it's triangular or not. Okay, let's talk about our stack of tortillas over here. We got our stack of tortillas. This is basically a very short cylinder. It was a little taller, but I ate a few of them. And it's easy enough to figure out the volume for this thing, because it's just a circle on top. So I know how to figure out the area of a circle. When I measure this thing in shugs and I measure it across, it's actually about 9, but to make our work easy, I'm going to say it's 10 shugs across. Because if it's 10 shugs across, we know that the area of this thing is just going to be, I've got a picture like this, and it's 5 and another 5. We know we know area is pi r squared. So it's pi times 5 squared. It's 25 pi, or whatever that number is as a decimal number. That's the base. That's how many cubes I have on the bottom floor, or on the top floor in this case. And we've decided that this thing is, 2 shugs high. So we just multiply how many things I've got on the bottom times how tall it is. And so it's 50 pi. And once again, if I want to know what that is as a decimal number, I plug in 3.14 and it tells me it's 150, or close to 150, a little bit more than 150. And once again, this is in units cubed, because it's how many little cubes, how many little sugar cubes would fit there in that space. As always, the surface area is a little harder, but I've already figured out the bottom. It's 25.5. I'm going to have the same amount for the top. It's 25.5. Those are my two bases. So for my perimeter, or my circumference, which I'll write out, circumference. It's a fancy name for perimeter for circle. I got the 25 pi for the bottom. Oops, I got to write it right. 25 pi plus 25 pi. And then the question is, well, how do I figure out the sides? Because it doesn't really have sides. It's got this circular thing. Well, this is where we have to get a little clever. So one of the things that we could do is we could wrap a piece of paper around it. Okay? And then we could unfold it. It's one long rectangle that we know is too high, because that's how high it was. It was 2. We could measure it, but do we really need to do that? Is there another way we can figure out how long that piece of paper is? And some of you are probably saying, yeah, that's just the circumference. Okay? So since we said this was 10 across, our circumference is, our diameter is 10. So this should be, if that thing was actually 10 across, should be 10 times pi, or 31.4 things long. And so let's go to our net. So this is what our net actually looks like. So this is our net. We've already figured out this is 25 pi for the area. Same down here. And then this thing is too high, but we know that it is from here to here. It's got to be 10 times pi, or basically 31.4 long. We do that times 2, we get 62.8. We add it to our 50 pi, which is the top and the bottom. And then if we want to turn that into a number we can. We could have left that back there. We could have just said this is 60 pi. It is 60 pi. That's probably the better way to do it. Okay, last thing. Let's talk about our egg. Once again, there's probably a formula for an egg. Maybe I'll throw it in there. But we're going to do sphere, because that is the other common. Think of this as a 3D circle. It is. If you took a circle and spun it in the air, and the path that it swept out would be a sphere. And so I'm just going to tell you what the formulas are for this. Okay? So our formula for the sphere for volume is 4/3. It's got to have a pi in it because it's round. R cubed, which kind of makes sense because cubic units. Maybe makes sense. I don't know. And then our surface area is simply 4 pi r squared. Okay? And if you'd either memorize that if you used it a lot, or you just look it up if you forgot it. But the practical problem with this is if we actually have a solid object, it's really hard to figure out what the r is. So honestly, one of the things that happens sometimes, and I'm not gonna use sugar units, I'm gonna use centimeters, is if you have a round object, what you'd actually do is you'd take a measuring tape and you'd go around the circumference, or the equator of our sphere, the great circle of our sphere, and we'd see something like, oh, this is basically 20 centimeters around. So if it's 20 centimeters around it, we know the circumference is, diameter times pi. If we know our circumference is 20 and diameter times pi, if we divide both sides by pi, our diameter is whatever 20 divided by pi is. Now I think I did that earlier, and it was, where did I write it down? Shoot, I know I wrote it down somewhere. I think it was 6, it was like 6.4. I hope it's 6.4. If it's not 6.4, pretend it's 6.4. I'll correct it later in the notes if I get it wrong. So that's the diameter. So this thing right here has a radius of about 3.2. And now that I've got the 3.2, I can plug it into either formula to figure out either the volume, how many little cubic centimeters now, because we changed units, how many little cubic centimeters would fit in there, or if we were doing surface area, how many little centimeters, 1 centimeter square in size would be pasted all over this little guy. Okay, that's plenty. Thanks for watching. Ciao.